Welcome to Cost Savings in the Energy Code, opportunities for operational savings in real world commercial buildings. Just a couple of housekeeping items before we get started. We are in listen only mode for attendees. We'll be making the use of the Zoom Q&A function. If you would like to ask any questions, down at the bottom of your screen, if you are on a desktop computer, you'll see a little bubble with a question mark. Go ahead and drop your questions in there as we move along. That makes it easier for us to find questions rather than filtering through the chat function. We will be recording this presentation and sharing it with attendees. And if you'd go ahead and enter your name and organization in the chat function so we know who is with us today. Next slide, please. All right, after the introduction of our speakers and a little project background, we're going to share our findings from our DOE study looking at lost opportunities for energy cost savings in commercial buildings, and we'll be sharing our insights into how to gain those savings back. And then we'll have plenty of time for questions at the end. Next slide, please. All right, our presenters today are Scott Hackle and Tianyao Zhang with Slipstream. I'll be facilitating the webinar. My name is Sherilyn Kelly, Manager of Building Energy Codes and Policy at the Institute for Market Transformation and Project Manager of the project. A little bit about our presenters. So Scott Hackle leads the research and innovations team at Slipstream in its mission to discover, test, and scale the strategies and technologies that impact climate and equity. Scott earned his bachelor's and master's degrees in mechanical engineering from the University of Wisconsin-Madison, as well as a graduate certificate in energy analysis and policy. He is an active member of both USGBC Wisconsin and the Wisconsin Advisory Council on Building Sustainability. So Tianyao Zhang is a senior energy engineer at Slipstream with a background in mechanical engineering and a Master of Science degree in architecture with a high performance building concentration. She consults with building owners, architects, and engineers to identify and recommend energy conservation measures in commercial buildings. Her building energy modeling and engineering expertise bring value to decision-making processes for project stakeholders. In addition, Tianyao applies energy modeling skills to conduct research on new energy efficiency technologies, market characterization studies, utility program design, and commercial energy code compliance assessments. Let's go to our next slide, please. So the project was made possible by a grant awarded by the U.S. Department of Energy's Office of Energy Efficiency and Renewable Energy Building Technologies Office to my organization, the Institute for Market Transformation. We work with the Pacific Northwest National Lab on key data analysis components on the project. Slipstream led on project participant recruitment and data collection. Their tireless work on this project really made it a reality. Slipstream also worked with Cyclone Energy Group, a commissioning agent out of Chicago who was pivotal in supporting recruitment and data collection as well. All right, I think we're all teed up, so I will hand it off to Scott to talk about project background.
Thanks, Sherilyn, and thanks everybody for joining us today. This was a long journey, and it's good to be sharing it now. The study outcomes that we were aiming for in this study look pretty similar probably to other code studies. If you're familiar with other code studies that have been done, we're looking to benchmark current practices to enable better codes and better enforcement and support of the codes. We really need to understand what current construction and design approaches are. We want to validate specific impacts of energy code elements, and then also identify opportunities or gaps where there's potentially things being missed. Next slide. But where this differs from a more typical code study is in the focus on complex HVAC and lighting controls, and a few other of the most complex elements of the code. That's really the focus of the study that we're going to be talking about today. And as such, it builds on the past codes work that had been done. You see a few studies that PNNL oversaw listed there: Nebraska, Iowa, Nevada. as well as some other states that have conducted code studies where they've had good success really understanding design and construction practice in a lot of building components, including heating and cooling equipment, wall insulation, roof insulation, and a lot of measures like that. But studies like those have tended to struggle to really capture what's going on in some of these more complex controls elements. The timing of when those controls elements get put into place certainly comes into play with that issue. The skill set that's needed to go and evaluate those elements of the code certainly comes into play, and just the fact of how complex they are comes into play. So this study was looking to supplement and complement those by specifically diving into those elements. Next slide. The study began in 2020, and so we just got going as the pandemic was hitting its stride, which is one of the reasons that this study did take a while. That slowed us up in the beginning, but we maintained our persistence and continued participant recruitment and data collection for a couple of years. We still needed to get some more buildings, and so in 2023 we added our research collaborator, Cyclone Energy Group, and as Sherilyn mentioned, they were really helpful and pivotal in getting us across the finish line. Both their vast network of different building practitioners that could help connect us to different building populations, as well as their ability in the field. And then that got us across the finish line, and we did the analysis and conclusion last year. And that brings us to today. Next slide. The research steps in, again, similar to other code studies, really take on three main components. First, need to recruit a set of buildings so that we can study them. And then there are two components to studying each building. A drawing review, where we really dive into the design elements, and then a site visit where we really dive into the construction elements. So this two-part approach of data collection really allows us to understand how code elements are being handled in both of those phases of the building life cycle, which you'll see leads to some nice nuanced conclusions as well. Next slide. I would add, just thinking about that timeline, et cetera, that those of you who haven't really been a part of one of these studies before, by far one of the most challenging elements is simply recruitment, just getting enough buildings to collect data on. And so we really appreciate any of you who are attending today that helped us line up buildings. Our networks really came through for us. So once we did get those buildings into the study, we went out and collected data. And the pictures on the right are actual data collection visits. We did a lot of, given that we were focusing on complex elements, we did a lot of digging through building automation systems to look at specific sequences and exactly what was happening in the buildings. In order to find these complex elements, we needed to have a sampling approach that would give us enough of those measures. So we looked at commercial buildings greater than 75,000 square feet. They had to be big enough to have the complex elements. We tried to spread across climate zones, so we'd have a mix. We looked at buildings built between 2020 and 2023, and that's really driven by the fact that we needed the controls and complex elements to be finalized when we showed up. We actually ended up visiting a lot of buildings right after they were occupied. So there are actually people in them, because that's often when the controls are finalized. There's still tweaks being made as occupants are coming in the door. We wanted complex HVAC systems. VAV was really common, water source heat pumps, other complex systems that have building automation. And then we needed to decide on a set of building types so that our results would be useful, representative, and have some statistical validity. So we ended up choosing office, multifamily, and school. And then within each of those building types, we looked at specific types listed there. So we did look at a couple different types of those three, but ended up organizing our results, and you'll see that in a minute, focusing on those 3 building types. Next slide. The participant locations that we ended up getting into the study are shown here. You can see a mix of buildings across different states with a significant focus on the Midwest, just given recruitment success there. We actually did also attempt to collect building data through a different partner channel in the Southeast, and that just didn't work out. Again, recruitment is very difficult. And so we ended up focusing in these areas. Next slide. That led us to this mix of climate zones, a mix of 4, 5, and 6. We unfortunately didn't get any in climate zone 3, but across 4, 5, and 6, that does give us some representation of the different levels of heating and cooling and the different ways that heating and cooling measures impact these buildings. Next slide. Oh, quick note on this. This bar chart was created using the 2015 IACC climate zones, because that's how we set up our sampling and how we were approaching climate zone modeling in this project as well. We recognize that those have since changed a little bit, but I don't think that affects the results too much. Next slide. And finally, here is how the building types fell out in the study. Pretty good mix of the multifamily, office, and school across the board. A little bit more multifamily just because there's so much of that being built everywhere right now. I'm sure all of you are finding that in your areas of the country as well. And I'll pass it back to Sherilyn.
Yeah, I think we'll hold on to these questions to the end, so I'll pass it off to Tanya.
Thanks, Sherilyn. Before we dive into the details of the findings, I wanted to quickly acknowledge the level of bias we had in our building sample. As most of you probably know, recruiting is always the biggest challenge and unknown with baseline studies like this. So in order to reach our sampling targets, we relied on many key partners, including energy efficiency programs, such as the ComEd New Construction Program in Illinois, or the Focus on Energy program in Wisconsin. We also relied on progressive institutions that were interested in sustainability right from the start. Like Scott mentioned earlier, we collaborated with a commissioning firm to help with the recruitment data collection. So all of that is to say that a portion of the buildings in our sample set would seem to have been skewed towards buildings that were built and operated by teams that care more about energy efficiency, or at least just paid more attention to these things. And if that assumption was true, it would suggest that the findings in the study are more likely to be underestimates of lost savings due to noncompliance and not overestimates. Another effect that this potential skewing in building sample has is in regards to the code compliance pathway. I'll highlight this again in a later slide, but in short, the buildings in our sample had a greater tendency to participate in green building programs and demonstrate their performance through energy modeling. And this tendency led to a higher than expected percentage of projects that complied under the performance pathway instead of the prescriptive pathway. I also wanted to touch on our methods for determining the energy code compliance pathway. It proved to be quite difficult at times, as we weren't always able to obtain this information from the project team. In many cases, there was no indication of code compliance pathway in the drawings themselves, so we had to ask for additional documents to verify this, which our site contacts may or may not have this in their possession. And also, finding the right personnel to confirm the compliance pathway also proved to be difficult, as a lot of folks that we were in contact with may or may not be well versed in this field. And establishing contact with the design team when the building has already been occupied was also not always feasible. So as such, we defaulted to the prescriptive pathway when no evidence is obtained to determine otherwise. The reason for this assumption is that anecdotally, we've heard from multiple stakeholders that the prescriptive pathway is considered an easier method to comply with, and many designers wouldn't go for a performance path unless there was a strong reason to do so. So for example, their windows ratio was too high and they couldn't make it work, the prescriptive path. That's sometimes they would consider a performance pathway for more of a design flexibility. We've also seen some cases of when the IACC prescriptive pathway was selected, but the additional efficiency package under Section C406 is often unknown. And when we encounter those cases, we assume that the default as a reduced lighting power additional package, as that's also an easier way to comply. So our building sample covered multiple states and jurisdictions, and as a result, we ended up with a mix of energy code versions. Some jurisdictions were still on ICC 2012 or ASHE 90.1 2010, whereas others may already be on ICC 2018 or ASHE 90.1 2016. Some buildings permitted under an earlier version of the code due to being under a long construction period, and a code change might have happened in that time frame. And regarding the breakdown between prescriptive envelope trade-off and performance compliance pathways, as mentioned earlier, we were not expecting the number of performance pathway projects to be this high. We had assumed that the prescriptive pathway would be what folks gravitate towards and it's easier means to comply. So we took a closer look at the potential reasons behind these projects that went with performance path, and it appeared that some prefer that greater design flexibility that comes with performance path trade-offs. Some had organizational sustainability goals of being X% more efficient than code, which required them to have an energy model to demonstrate building performance. So the total lost energy cost savings due to non-compliance were calculated through a spreadsheet calculator that was developed by the Pacific Northwest National Lab. And one critical input in the calculator was specifying whether a measure was a verified observation or an inferred observation. So verified observation, that means that it was something that we could physically see while on site. And inferred meant that it was just not directly observable in the field, but we did have some secondary source to determine its condition. And only the results of verified observations were included in the analysis and the final results. The reason for that was because this allows for a higher confidence level in the data and the conclusions. About 80% of all applicable measured instances were verified, and 20% were inferred or unknown. So we got the majority, but not all. Also, not all energy code measures were included in the study. Some measures were just not applicable to the building types or the climate zones that we focus on. And all of that is to emphasize again that the results are a conservative estimate of lost energy cost savings. So the data analysis results are shown here, and we can see that office and school buildings have a comparable annual loss savings per floor area, with schools just being slightly higher. Multifamily, on the other hand, has a much lower value than the other two building types. That may be due to a few reasons. To start, many of these complex control code elements are in regards to the design and operation of VAV systems, which generally are not seen in multifamily buildings. Multifamily is usually served by water source heat pump or fan cool units. So these VAV measures don't typically apply to multifamily. And one of the bigger impact code elements, like demand control ventilation, that can amount to significant loss savings if found to be non-compliant in an office or a school. But for multifamily, it typically only applies to a very small square footage of the building, like the common areas, if it's even applicable at all. So there are less instances of having an impact there for these like bigger impact code elements. And what's more is that multifamily buildings are occupied 24/7, which means that some of the code elements that are related to nighttime shutdown do not apply. So in short, some of the high impact, high risk measures are either not applicable or just do not apply to a significant floor area in multifamily buildings, resulting in multifamily having a much less loss savings on a per square foot basis. And when looking at all the buildings in the sample together, there is a large range between the least amount of loss savings per square foot and the most amount of loss savings per square foot. It's really interesting to note that none of these sites fully met the energy code requirements. And this large variance of compliance between buildings, that gives us something to think about, as that suggests that compliance is achievable. But the question is, how do we consistently meet code for all of these buildings, and what practices could be put in place to achieve that goal? When we look at loss savings by compliance pathway, we see that performance path projects have less loss savings per square foot. However, does that necessarily mean that performance path projects are more likely to participate in green building certification programs and be more inclined to implement energy efficiency measures? Or do top performing projects go with performance path to begin with? It's somewhat inconclusive for whether performance path results in lower cost savings, as we can't really say for sure what's the cause and what's the effect, but it's an interesting data point to think about. And when we look at loss savings by energy code version, we see that the ICC 2018 or the ASHE 91 2016 has the least amount of loss savings per area. and the 2015 ICC, or the ASHE 91-2013, that has the most loss savings per square foot. This is interesting because the pattern isn't consistent with the code updates. Our hypothesis here is that, in general, designers are more familiar with the requirements of older versions of the code, so there will be likely to be less loss savings in buildings complying with ICC 2012 rather than ICC 2015. But for buildings under ICC 2018, we suspect that the sampling bias that I had mentioned earlier, that plays a bigger role in here. I had talked about relying on key partners that value sustainability for building recruitment, and many of the projects that those key partners brought in were under the ICC 2018. So this again is another part where sampling bias had a bigger effect on the analysis and results. Okay, so in order to dig deeper into where all the loss savings come from, we took the loss savings per square foot by measure and ranked them from high to low and picked out the top 15, which are shown here. So these are the ones with the highest impact and where we can really focus our efforts on. Several of these measures are considered to be more complex elements of the energy code, and that supports our finding that complexity is tied to compliance. So here are the same 15 measures, but categorized into several buckets for more easy analysis. So this gives us a better picture of the types of measures that are high impact in loss savings. We have them grouped into VAV system specific measures, general HVAC control measures, nighttime shutdown and setbacks, commissioning, and finally miscellaneous measures. So we summed up the loss savings per square foot in each bucket to come up with this graph here just to see the impact by measure category. And it's pretty clear that there's a lot of potential for improvement in VAV system design and operation, as well as general HVAC controls. So now we can take a closer look at each of those measures within each category, starting off with the complex measures in the VAV systems. So the first one here, VAV ventilation optimization, that's the highest measure for loss savings per square foot. This measure did not appear to be implemented in any of the projects that we've seen so far. And it's not surprising because this measure has been proven to be a pretty complex code element that many design engineers, contractors, and facility managers do not fully understand or just confuse it with demand control ventilation. So this is a good example of an element that needs additional training in both the design and controls community. The next measure we have here is the multi-zone VAV systems shall have zone controls configured to reduce the volume of air that is reheated, recooled, or mixed in each zone. So this is also a high impact measure in the sense that even though there weren't as many projects that did not comply, it still resulted in a lot of loss savings to the point where I ranked this measure to be among the top 5. So loss savings here come from zones exceeding the maximum allowable airflow for reheat at the terminal boxes. In a few instances where we observe noncompliance, it seems to be an issue that originated at the design stage and then got carried over to operation. So the third measure we have here is static pressure reset. We've seen that for many buildings with VAV operation, the VAVs, they operate on a fixed pressure set point and do not have any set point reset controls. And for the systems that did have static pressure reset controls, it was also proven difficult to implement a maximum set point of 1.2 inches while still being able to supply the amount of airflow needed at the terminal units. So that signals a potential sensor misplacement issue, which again may be something that got missed during the design phase and then got carried over to operation. So all 3 of these measures listed here, they have a common theme going on. They are considered complex elements of the code, and their level of complexity has resulted in a higher tendency of being missed during the design phase. And here we have some example screenshots of BAS settings that reflect a control sequence that's below code. So to the left here, we have a setting showing how the static pressure control is on a fixed set point rather than on a reset control. And to the right here, these 2 graphs all show the maximum limit exceeding the 1.2 inches that's required by code. And next we have general HVAC controls. So for demand control ventilation, we found that it is not always included in the design in areas where it's required by code. And in some cases, it was included in the design, but for some reason not implemented in the BAS. Regarding thermostat deadbands, most deadbands that we've seen were found in a 1 to 3 degree range. This is a potential cause for systems to constantly switch between cooling and heating modes, which leads to inefficiencies. Many of the facility managers that we talked to, they were unaware of this code requirement. And in many cases, the design documents did not specify a thermostat deadband at all, signaling that the designers may not realize this is something that needs to be called out in the drawings. And in a few cases, this was documented as code compliant in the original design, but the design sequences was not carried out in the BAS, or it was changed by building operators shortly after occupancy. And regarding the energy recovery requirement, we found that a lot of mixed air AHUs with high outside air percentages and high supply air flow rates, they have a greater tendency of not meeting code on this element. So this is an issue that is typically found in the original design and then got carried out into construction, which seems to suggest an oversight in design. Dedicated outside air systems, however, they are almost always found to be compliant with ERVs. So these measures ensure there are generally things that can get missed in design or in the controls programming when the building is occupied. Here we just have some more examples showing the thermostat deadband being less than 5 degrees, which is what code requires. Here's another example of a mixed AHU that does not have the code required energy recovery ventilation. And for the next measure bucket, nighttime shutdown and setbacks. So these are all low-hanging fruit that would be pretty easy to implement and save a ton of energy. We found that a handful of buildings were operating 24/7, even though they were unoccupied overnight. So the common theme for these buildings was that they were all originally designed to meet code, but the design sequence didn't actually make it into the BAS programming. For thermostat setbacks, one thing we have been hearing pretty frequently was that the code required setback values were just too aggressive. We've heard that many facility managers felt that their systems could not bounce back to their set points in time for morning occupancy from the setbacks that were as aggressive as what was required. And in a few cases, this was something that was originally designed to meet code, but the design sequence either didn't make it into BS programming or was just changed by the building operator after occupancy. So here's an example showing a classroom building having the HVAC schedule set to be unoccupied 24/7 when we did confirm that the classroom was unoccupied overnight. Here are just some more examples showing the thermostat heating and cooling setbacks not meeting code requirements. And in regards to commissioning, a small sample of projects did not complete the code required commissioning for lighting and mechanical systems. But for mechanical commissioning, the issue was more with who was conducting the commissioning. So code requires a third-party agent to perform the activities, but we found that for some buildings, they had utilized their own design team to carry out commissioning activities, which may have led to a potential conflict of interest. And in regards to the miscellaneous code elements, we just zoomed in on the two measures that we saw that were frequently not in compliance. So the first one here is the automatic plug load controls. So this is not required by ICC 2018 and earlier versions of ICC, although it is required by ASHRAE. And we found that where applicable, there were very few buildings that actually met this requirement. It seemed that many designers were unaware of this requirement to begin with. And in one case, the automatic plug load controls, they were included in the design and installed in construction, but was later disabled post-occupancy in response to tenant complaints, which may warrant some deeper investigation that we weren't able to do under the scope of this project. And as far as lighting controls go, daylighting controls is the one place where we have seen the most non-compliance in. There were instances where we saw lights adjacent to large windows that looked like they would have been required to have daylighting controls, but the lights did not appear to dim even when it was bright outside. And this seems to always be an issue that originates in the design phase and gets carried over to construction and operation. And in addition to the high impact verified loss savings measures, we also wanted to quickly highlight the two highest impact inferred loss savings measures, which are these two, the fan power limit requirement for VAV and constant volume package systems. So we found that for many of these large VAV systems, they utilize custom-built air handling units. And for these custom-built AHUs, we were not able to verify the total power for all the supply and return fans in the field So for that reason, we recorded all of these instances as inferred rather than verified. But there does appear to be a pretty high non-compliance rate for this measure just based on plan review alone. And there's a pretty good chance that this non-compliance would have been carried over from the design to construction. And because of that, we feel more confident in the lost savings implications from just these two inferred measures. So these are pretty high impact measures with little remedy options post-occupancy. So it's one of the things that are important to get right the first time around. So note that the loss savings for these two inferred measures, they're not included in any of the summary tables that I went through previously, which again reinforces the point that what we're presenting as total final results are conservative estimates. Cheryl, I don't know if you wanted to look at questions first before we jump into conclusions, or do we want to run through everything?
Let's keep going with conclusions. Thanks.
Okay, great. So let's move on to conclusions. So we found that compliance varies significantly between buildings, which kind of signals that this industry could really benefit from practices that are put in place to have buildings built more consistently to meet code and not just the ones that are sustainability focused. We've seen that some of the most complex elements of the code have very poor compliance, which is where code writers should definitely focus their efforts on and seeing if there could be a better way to phrase a requirement that leaves less room for misinterpretation. There could also be more resources to help the design industry interpret these complex elements and a channel for them to ask for help. We've seen that some elements were missed in design and some were missed in implementation. So understanding the reasons behind the non-compliance may also help create a roadmap as to where to drive our efforts, as well as determining which audience we should target for which measures. Some things might be a perceived risk or a misconception. So how do we increase awareness about the intent of the code and address the misconceptions? We also recommend a broader adoption of ASHRAE Guideline 36 by the market as a whole, which can potentially help address some of the controls issues we're seeing. Guideline 36 that was created to develop and maintain the best-in-class standardized HVAC control sequences. So if we had a BAS package that is pre-programmed to meet the Guideline 36 and controls contractors also trained on Guideline 36, that could definitely help reduce the amount of time for engineers and contractors in programming and commissioning of the systems. We also wanted to highlight the importance of the timing of the site visits to observe the code elements. As many of a building may need to be visited multiple times at different construction stages to be able to verify certain code elements. And in the timing of the site visits for code officials, that doesn't always allow for review of all of the control elements. So that's indeed is a barrier from the code inspector's perspective in getting a building fully reviewed and all of the code elements verified. So lastly, we found that for almost every applicable HVAC lighting control element that was verified, there was at least one instance where it did not meet code, which again signals that additional training and education is much needed within the industry as a whole. So since code writers play such a huge role in code adoption and compliance, one recommendation we have for them is to try to simplify the complex elements of the energy code, or just simplify the way complex measures are required to be implemented. We recommend leaning on simpler measures where possible, even if that means less savings per measure. We could also have less aggressive requirements in the code in order to aim for the majority of savings instead of the highest achievable savings possible. So hopefully through these strategic decisions, code writers can help make the code more accessible to all markets. And here we summarize some of the possible reasons for code control elements not meeting code. It could be unawareness of the requirement or the building operators having had a negative past experience. We've heard about that on setbacks and optimal start controls. It could also be the perception of a reduced risk of tenant complaints, or it could simply just be due to insufficient quality control and something that's fell through the cracks due to oversight. So depending on whether it's a design, construction, or operation issue, we can target different audience for training and intervention. And the audience for training and education can include all members of the industry, from the design community to the construction community, to the commissioning agents, and finally to facility managers and operators. Bridging the knowledge gap for all of these entities that can really help promote a smoother adoption of new practices and approaches. So here we summarize a short list of code elements that we believe would be beneficial for each community to have increased training and education on. You'll see that for some code elements, they pop up for each of these communities. So there could really be some targeted training applied there. Hopefully by bringing each community on the same page regarding all of these control code elements, that will really help reduce the number of instances where things fall through the cracks. And support for the code communities can be through circuit writers, code collaboratives, third-party enforcement, or other code support programs, and ideally should focus on elements that belong to one or more of these categories shown here. So the first category that's in regarding the code elements that are frequently observed to be below code. Even if the individual building loss savings per square foot may be small, the aggregate loss savings of a building stock can easily add up. The second category here is regarding code elements that have a high energy impact or just high loss savings per square foot. So for these elements, even if only a few buildings do not meet code, there's still a considerable amount of savings left on the table. And the last category is regarding elements that are the newest addition to the latest energy code version. So these are often things that get overlooked or has a higher chance of misconception. So in summary, HVAC and lighting control elements, they have historically been pretty difficult to increase compliance on, as there are multiple entities involved in the design, construction, and operation process. So that leaves a lot of room for misconceptions or oversight. Our goal for the study is that the findings here can be used to better inform practices to improve design and construction trends, and as well as address the knowledge gaps through trainings, interventions, and future code updates. And I think we can jump to questions now.
Awesome. Thanks, Scott and Danielle. We do have several questions in our Q&A, and folks, please keep adding to that. We'll go to our first question from Shannon. Is the installation of outside airflow measuring stations required by Energy Code to fulfill the ventilation requirements, or does the code require controls to be in place to make sure throughout the life of the building the required minimum outdoor air is always provided?
That I will need to double check the code on because I talked about demand control ventilation. It's about reducing the level of outside air when there's like variable occupancy. It's not directly the same as the question about measuring stations. So I'm not quite sure about that. I can get back to you on it.
Alex asks, are outside airflow measuring stations required to meet code compliance if minimum outside air ventilation can be demonstrated to comply through other methods?
I believe that again is similar to the previous question, but I'll have to get back to you both on that.
Yeah, I can add a little color to. We were primarily looking at energy code. We were essentially only looking at energy code elements and elements that save energy in buildings. And of course, there's a lot of other considerations in building operations, including health and indoor air quality and ventilation. And there are ventilation standards to go along with that. The standards do require that if you're doing a certain level of demand control ventilation, which is, we did find in a number of the buildings we went in, and your HVAC system has the level of complexity of a lot of the buildings that we have, that the standards do require that you have some amount of airflow measurement. And so that tends to go along with that demand control ventilation element, as Danielle mentioned, but it wasn't something that is required by the energy code per se. And so it wasn't something that we checked.
Thanks, Scott. David asks, can you go into more detail on the impact of setbacks on efficiency? Did the team verify the time it took buildings to get least required temps?
We did not look at the impact of that. We just documented what we saw at the time of the site visit. But we believe that if buildings were to implement the optimal start programming, that can automatically get the buildings bouncing back up to their set points before occupancy, and that could help alleviate the issues there. But we did not do any sort of like verification of testing what temperature or how early the setbacks need to be in place to have the building bounce back.
And to the comment about least required temps, it was certainly a mix of timing on our visits, but we often, especially as the study went on, realized that it was better to show up a little bit after occupancy when a lot of these things had been finalized. And so I do think we got a mix of some buildings where that had tenants come in and their tenant space temps were set and final, and others where we were there beforehand.
For the lights adjacent to windows that did not appear to dim, how was it verified that they did not dim? For example, eyeball, light meter, power meter, etc.
We mostly eyeball. We did not use any light meters to measure the light levels at the time of the visit. And we verified this with the facility manager that those lights appear to be always on one setting from 0% to 100% and did not observe any like in between setting.
Why is it that so many projects didn't have commissioning and testing of lighting controls?
That appears to be, it might be an oversight from the design team perspective. Because when we talk about commissioning, most folks are very aware of the mechanical system commissioning, but they may not be as aware of the lighting controls commissioning requirement. It may just be unfamiliarity with the energy code on that aspect.
Most of these issues are solved by simply enforcing the codes by local jurisdictions. Did you see any correlation between cities that enforce code and those city-states that don't?
I believe all of these jurisdictions do enforce codes, but that I guess that comes back to the question, one of our conclusions about the timing of the site visits from the code officials. So they will need to visit the building at the right time to be able to verify these control elements, and that does not always happen. So it could be that this was something that they were not able to check at the time of their visit.
Yeah, I agree with that response. I feel like there's a thought I'm trying to put together here. I think there is a angle to look at this from that suggests, okay, we really just need a lot more enforcement, and enforcement that has both the time and the expertise to look at all of these items. And that is, I think, and that was one of Tignal's conclusions that she mentioned a bit ago. If we could have some additional third-party help for code officials, circuit riders, training, that's all beneficial. And we see that now with some of the efforts that are occurring in some of these states that we're looking at. But those efforts will never be perfect, and those efforts are not occurring in every one of these states. They're stronger in certain states. And I know we have different folks in the audience today. It's tempting to think of this as somebody else's problem and recognize that, and if I'm a designer or maybe I'm a contractor and I'm building buildings, all of us are really pressed for budget and schedule, et cetera, across the board. But I think there's a space for all of the trades and all the actors in these buildings to make improvements on how the codes are written, in how we're training designers and how designers do their jobs within that trade, et cetera, down the line. We're never going to have the level of code enforcement on these types of items. They're really challenging items that allows code enforcement to take care of the problem, in my opinion, entirely. Again, we should work on that and provide training and third-party support and all of those things, but that's never going to be the solution. The only solution.
Are there any plans to review losses due to non-compliant building envelope?
I think we're addressing it in some of the recce studies. I'm not sure, Scott, if you want to talk about that, but within this study, it was just mostly on control elements. So future studies may include that.
Yeah, I would say it's interesting, this study focused most on high-rise multifamily and on commercial. there have already been a number of code studies in these states on low rise and maybe some mid-size multifamily that have included airflow testing and envelope elements with more robustness than we were able to here. And yes, some of the new RECI funded studies, especially those focused on multifamily, and in particular the smaller and mid-sized multifamily, not the largest, are doing a lot more envelope testing too. So I think there are other studies out there to look at for that area. Certainly insulation level, that's a standard thing that's covered in almost all the code studies out there that you can find. But I think the airflow testing and insulation detailing, et cetera, is probably more interesting than just the number of inches of insulation. And that is being covered in some of those studies, not all, and a little bit less so in this one.
Years back, infiltration was considered to contribute to OA calculations, with the newest code requirements where the tight building envelope is the goal mechanical. I think this is actually just more of a statement. One down here, do you think requiring more commissioning and building codes would result in better compliance?
Yes, definitely. I feel like some of these control elements, they would get fixed at the commissioning stage before even moving on to occupancy. There was one case where we saw that in the design drawings, the DCB sensors were specified in the drawings and they were purchased at construction, but they did not end up getting installed due to an oversight from the contractor's part. That could have easily been caught by commissioning if that were to happen.
Agreed. And there was a comment made here in the chat, lack of commissioning is due to lack of enforcement. And that's an element where I'd connect the previous question that I was answering about enforcement. And that is an area where I do think if we have a limited amount of time to get code officials to enforce things, maybe that's one where we should focus. We definitely saw a lot of gaps in the ability and the documentation and everything around commissioning. And if you can enforce the commissioning elements and get those to occur, and then hopefully the commissioning agents can take care of some of these more detailed elements, I think there's something there.
These findings are very similar to a P and an L presentation that I saw at ACEEE around 2016 that found that equipment was provided that had the capabilities to achieve HVAC control codes, but were never properly programmed. About what percentage of the lost savings do you think could be captured through a program that goes into recently built buildings and making low-cost control programming and minor control updates?
That's a great question. We will probably need to do additional analysis to figure out the level of savings that we can get from that sort of program. But definitely implementing a low cost, no cost program like that just to save on control elements, that would be really beneficial.
Couple more questions here. Do all code requirements inherently mean a building will be more sustainable?
For the most part, that is the intent of the energy code. So I would say yes. It's more of a sustainability focus for all the energy code requirements.
Can this be repeated for even older buildings? Could the potential savings be put in a percent of actual usage?
Yeah, for older buildings, we will definitely see more savings because you're comparing it to an existing condition versus comparing it to code compliant conditions. And as far as putting it into like percentage of savings of the total building energy use, since we did not do any sort of like building energy modeling or obtain any of the utility bills, we don't have a great sense of what that percentage would be, but that would be a really interesting study for future analysis.
How could more emphasis on quality control be highlighted in the industry?
Oh, sorry, what was that?
How could more emphasis on quality control be highlighted in the industry?
Yeah, so that's, I guess, relation to what I mentioned about some things getting missed in design, we definitely would recommend having some sort of quality control QA/QC procedure put in place that some of these elements that are mostly complied with by the industry, but only a handful of projects did not comply with. So that kind of signals that there need to be some sort of QA/QC procedure put in place for those entities, and it's more of a procedure thing to put in place. I'm not sure, Scott, if you have more thoughts on that.
Yeah, you use a designer as your example there, which is good to think about that context. But I see the use of the word industry in that question, and what immediately jumps to mind is we really are kind of talking about, there's one big industry, which is the building construction, but the individual trades and industries within that each probably have a different set of steps they could put in place. So you talked about the design elements. I think there's some of the same things can be said on the construction side, and commissioning is certainly the QC strategy of choice, or a leading best practice for QC in that industry. I would also argue, even within commissioning itself, within that industry, there are some practices that could be improved. And we saw that in documentation and how that's provided, and the dialogue between commissioning agent and code officials. And then certainly within the code official side, getting some more sort of standardization. And I think standards are helpful. And I mentioned the word standardization. I would just go back and reiterate one of your conclusions, Tinya, about guideline 36. Now, that's not technically a standard, it's a guideline, but it has some sort of similar effects to standards, or the notion of standardization in general. Those types of things are, I think, tremendously helpful, where we can put more of those in place around, to use some of the same examples, commissioning and other things, and get industry to actually follow those in their industry best practices. That would be really helpful.
All right, folks, we're closing in on our last few minutes here. If you've got any final burning questions, go ahead and type them in, but just a couple more here. Were you able to revisit any sites pre and post occupancy? Can you speculate on how compliance is maintained following a few months of tenancy?
Due to budget constraints, we were only able to visit a site one time for these buildings. We weren't able to tell how much of an effect occupancy had on these control elements. There's definitely the possibility of some things being changed post occupancy, like something could be programmed to meet code when the contractor hands it over to the facility manager, and then later gets changed as more tenants move in.
It's a great idea. Great idea for another study, though. We could try to come back to the mall, get some funding to go back to the mall. If anybody's interested in partnering on that, reach out.
All right, last question here. What was the % compliance with HVAC commissioning?
I will need to go back to the analysis and look at that. We didn't really look at compliance rates, but we were more focused on total lost energy cost savings. So that will be a metric we'll need to go back and look at.
Awesome. Okay, that looks like the last of our questions. You want to move to our last slide here? Okay, folks, thank you so much for joining us. Thank you for all of the excellent questions. Really appreciate the participation. And another thank you to the U.S. Department of Energy's Office of Energy Efficiency and Renewable Energy, Building Technologies Office, a title that just rolls off the tongue. Appreciate the funding and support on this project. And big thank you to Slipstream and Cyclone for making this possible. And everybody have a great afternoon. Thank you.
Thanks for joining us, everyone.
Yeah, thank you.